Hello students, welcome to the EPG Pathshala. My name is Dr. Rajeshwari Sinha and in today's lecture we are going to learn about statistical tests. Statistical tests form an important component of biostatistics. Let us see what objectives we are going to address in this lecture today. We will look at what do we mean by statistical tests, why it is important, and what are the different types of statistical tests that are commonly used. We will see that there are about 10 to 12 kinds of tests that we will use today. As we discuss each test, we have summarized the formula that is used for calculating the particular parameter relevant to the statistical test. We hope that you have an enjoyable time listening to this lecture. Statistical tests. These tests are based on the type of research questions which are to be answered. Two basic types of questions are the degree of relationship or dependence among variables. The statistical tests used in these cases therefore answer the question as to whether there is any relationship or dependence among variables and whether this can be considered statistically significant. The second type of question is the significance of group differences. The statistical test used in these cases answer the question as to whether an observed difference is probably just due to random factors or is it due to the treatment factor and large enough to be considered statistically significant. In this slide, we see the different types of statistical tests. These include independent t-test, Mann-Whitney test, paired t-test, Wilcoxon signed rank test, one-way ANOVA, Kruskal-Wallis test, repeated measures ANOVA, Friedman test, chi-square test, odds ratio and relative risk, Pearson's correlation coefficient, ranked correlation coefficients, and the Z test. Independent t-test. The independent t-test is used for comparing the means of two independent groups or variables. This test is used when data is normally distributed. P less than 0.05 indicates that there is a significant difference between the means of the two groups. The formula for the independent t-test is given below. Man-Whitney test. The Man-Whitney test is the non-parametric equivalent of the independent t-test, that is, this test is applicable when data is skewed. This evaluates difference between two independent groups or variables taking into account the magnitude and direction of difference. In this test, all the data is first ranked, following which the ranks of each groups are summed up and are compared to determine similarity between the groups. The formula for Man-Whitney test is given below. Paired t-test. The paired t-test is used to test for the difference between two variables which are related. The test assesses whether the mean of the paired differences is 0. A value of p less than 0.05 indicates statistical significance of the result. The formula used for paired t-test is given alongside. Wilcoxon signed rank test. This is the non-parametric alternative to the paired t-test discussed previously. The test compares two samples which are related or matched and examines whether there is a difference in their population mean ranks, also simultaneously taking into account the magnitude and direction of difference. P less than 0.05 indicates there is a significant difference between population mean ranks. In the formula given alongside, T is the Wilcoxon signed rank test statistic given as the sum of positive ranks. It is calculated as the absolute differences are first ranked, all positive ranks R plus and negative ranks R minus are summed separately. The smaller of these two sums in the absolute value is given as T. One-way analysis of variance or ANOVA. This is an extension of the t-test for 3 or more independent groups and detects the difference in means of 3 or more independent groups. To decide whether differences between the groups are statistically significant or not, the ratio of variance between the group to the variance within the group is considered. A value of p less than 0.05 indicates significant difference. Repeated measures ANOVA, tests the equality of means in 3 or more groups within the same subjects. The formula used in one-way analysis of variance is given alongside. Kruskal-Wallis Test. This test is the non-parametric equivalent to one-way ANOVA. The test compares the medians of 2 or more samples. P less than 0.05 means that the test results are significant, and the formula is given below. The Friedman test. This is a non-parametric equivalent test to repeated measures ANOVA and is used to detect differences in scores across multiple occasions. Scores are first ranked for each subject. The sum of the ranks for each condition is used to calculate the test statistic. The Friedman test formula is provided below, and a statistically significant result has P less than 0.05. Chi-square test. The chi-square test is another test used to measure the association between variables that are categorical. It is the measure of the significance of the association. Chi-square tests are used to decipher association between nominal data. If there is an association between two variables, chi-square will be called significant. When there is no association, chi-square is non-significant. Chi-square test can also be used as a measure of goodness of fit. It is denoted by the Greek letter chi-square. The formula is given below. So students, we have now reached midway into this lecture. We hope you are finding this lecture useful. So far, we have looked at some of the common single comparison tests, namely independent t-test, paired t-test, one-way ANOVA, and some of their non-parametric counterparts, namely Man-Whitney test, Wilcoxon signed rank test, Kruskal-Wallis test, and the Friedman test. Let us now move forward and see the concept of odds ratio and relative risk. Moving on, we will make an effort to understand some other tests of association, such as the Pearson's rank correlation coefficient, the Spearman's rank correlation coefficient, the Kendall's tau rank correlation coefficient, and the Z test. Let us have a look. Now we come to odds ratio. Odds ratio measures the strength of association for categorical data. It is derived from a case control study and is obtained as a ratio of odds of disease in exposed to the odds of disease in the non-exposed. The interpretation of the value of odds ratio is as follows. If the ratio is less than 1, the event is less likely to happen. If the ratio is more than 1, the event is more likely to happen. Relative risk or risk ratio. This is given by the ratio of probability of an event occurring in an exposed group to the probability of the event occurring in a non-exposed group. It is used in randomized controlled trials and cohort studies. The interpretation of the values in relative risk are given below. If the value is 1, there is no difference in risk between two groups. If it is less than 1, there is less risk in the exposed group as compared to the unexposed group. If the value of relative ratio is more than 1, there is more risk in the exposed group as compared to the unexposed group. Calculation of odds ratio and relative risk. In this slide, let us consider two groups, group 1 and group 2. The number of times the event happened in case of group 1 be A and that in case of group 2 be C. The number of times the event did not happen in group 1 be B and that in case of group 2 be D. The odds ratio is given as AD divided by BC, whereas the relative risk is given as A into C plus D divided by C into A plus B. Pearson's correlation coefficient. This is the most commonly used correlation coefficient, represented as ρ. It measures the strength of a linear relationship between two variables on a continuous scale. The coefficient R takes on values -1 to +1. When the value of R is -1 or +1, the relationship is perfectly linear. When the value of R is 0, relationship is non-linear. A positive correlation takes place when the value of R has the value between 0 and 1, and a negative correlation is there when the value of R lies between -1 and 0. Pearson's correlation coefficient formula is given in this slide. The variation in one variable x has a constant ratio to the variation in the corresponding variable. The relationship between the two series is therefore linear. Spearman's rank correlation coefficient. This is based on the ranking of variables. It helps on dealing with qualitative characteristics. It is denoted by rho or R. This was introduced by Charles Edward Spearman in 1904. It is used to measure the strength of association between two variables which relate in a monotonic function. To calculate this, the variables in the dataset are first ranked and compared. The Spearman's rank correlation coefficient is obtained by the formula which is given below. Another formula for Spearman's rank coefficient is also provided. Spearman rank correlation coefficient interpretation is as follows. If the value of rho is -1, there is negative correlation. When it is 0, there is no linear correlation. When it is 1, there is positive correlation. Advantages of the rank correlation coefficient include that it is simple to understand and easy to evaluate and can be used to understand the relationship between both qualitative and quantitative data. Kendall's tau rank correlation coefficient. The Kendall's tau rank correlation coefficient given by tau measures the association between two measured quantities. Tau value ranges from -1 to +1, indicating complete negative association to positive association. T equal to 0 or tau equal to 0 means no association. The formula is provided below. The proportions test or the Z test. The Z test is used to assess whether the proportions of two populations differ significantly with respect to one characteristic. If p is less than 0.05, the results are said to be statistically significant. The value for the Z test is calculated as provided by the formula below. This slide shows the summary of the key statistical tests which we have observed in this module. These include the parametric tests and their non-parametric counterparts. At first, we look at the common single comparison tests, for example, independent t-test, paired test, one-way ANOVA, two-way ANOVA, repeated measures ANOVA. Then non-parametric counterparts like the Man-Whitney test, Wilcoxon signed rank test, Kruskal-Wallis test, Friedman's test, etc. This is a continuation of the previous slide and further gives summary of the statistical tests we have studied. This slide summarizes the various tests of association like the Pearson's correlation coefficient, chi-squared test, Spearman's correlation coefficient and Kendall's tau rank correlation coefficient. Students, we have now come to the end of this lecture. Thank you for being there with us. But before we end, let us summarize what we have learnt in this lecture today briefly. Statistical tests are based on the type of research questions which are to be answered. The two basic type of research questions are the degree of relationship or dependence among variables and the significance of group differences. The different types of statistical tests are discussed below. The independent t-test is used for comparing the means of two independent groups or variables. This test is used when data is normally distributed. The Man-Whitney test. The Man-Whitney test is the non-parametric equivalent of the independent t-test, that is, this test is applicable when data is skewed. It evaluates difference between two independent groups or variables taking into account magnitude and direction of difference. The paired t-test assesses whether the mean of the paired differences is 0. The Wilcoxon signed rank test compares two samples which are related or matched and examines whether there is a difference in their population mean ranks, also simultaneously taking into account magnitude and direction of difference. Further, the one-way ANOVA or analysis of variance is an extension of the t-test for 3 or more independent groups and detects the difference in means of 3 or more independent groups. The Kruskal-Wallis test compares the medians of 2 or more samples. The repeated measures ANOVA method is used to test the equality of means in 3 or more groups within the same subjects. The Friedman test. This test is used to detect differences in scores across multiple occasions. Scores are first ranked for each subject. The chi-square test is another test used to measure the association between two variables which are categorical. It is the measure of significance of association. The odds ratio measures the strength of association for categorical data. Further, the relative risk or relative risk ratio provides the probability of an event occurring in an exposed group to the probability of the event occurring in a non-exposed group. Now let us see what is Pearson's correlation coefficient. It measures the strength of the linear relationship between two variables on a continuous scale. The Spearman's rank correlation coefficient measures the strength of a monotonic relationship between paired data. The Kendall's tau rank correlation coefficient, which is represented by the Greek alphabet tau, measures the association between two measured quantities. The proportions test or Z test is used to assess whether the proportion of two populations differ significantly with respect to one characteristic. Thank you for watching this lecture on statistical tests.